Hey friends, thank you very much for joining me again. Today we continue our discussion on data structures and algorithms. And if you've been here in the previous episode with me, I discussed about array list and how it works behind the scenes. We even created one ourselves. Today we continue our discussion with a different list implementation. I know you have used it already, linked list, but do you know how it works and how it differs from array list? As I was saying in the previous episode, we used to use array list as a default in the majority of cases, and most likely 99% of the cases we just choose it because it seems to be the most appropriate. But is it always the most appropriate? Does it always work for us? I have explained in the previous episode when and how those operations might impact the performance, and since we discussed the behind the scenes and how it works, you have seen that in some cases the complexity for an array list might be larger. Let's see a different kind of implementation for a similar collection, a list again, but with a different implementation behind the scenes, so working with a different algorithm behind the scenes. And same as in the previous episode, we'll try to take it together, analyze the operations, implement at least a part of them. I don't know how many we'll be able to implement, but again, if the time doesn't allow us to do everything and it's still important stuff that has to be discussed, as you know, I will continue the discussion in the next episode. With that being said, I think we can actually start by sharing the screen, and I have created a plain empty project, so nothing here, absolutely nothing. And what we want to discuss about today is again linked list. No, so linked list, you have created probably one before, maybe you've even worked with it, but how does it actually work, and what kind of operations is more appropriate to use with a linked list? So when would I choose a linked list instead of an array list, for example, might be a question. So you need to think very practical. No, we will not discuss only data structures and algorithms here in this stream as you did in the university. I want to focus on practicality of the things we discuss, and the practicality today is, when do we choose the linked list? How does it differ from the array list? So how do we know which are the cases, which are the scenarios where I would prefer to choose an array list and where I would rather prefer to choose a linked list? No? But to answer that, let's see how linked list works behind the scenes. So a very short notice is that I will discuss today a little bit more than just linked list. I will discuss I will tell you that there are a couple of types of these kinds of lists, and we will classify this in single chained lists, or single chained linked lists, whatever you want to call them, and double chained lists. And I would like to start with the single chained lists today, and depending on the time, continue with the other, maybe also in one of the next episodes. But theoretically, linked list is a double chained list. So I want to make clear from the very beginning that I want to discuss both data structures, but if you want just to refer to linked list, then this is the second one that we will use. Yeah. So Raul, I see a question. If possible, please explain the implementation given by Java already. It will help us to understand the data structure more. But that's actually what I'm doing, isn't it? Or would you like me just simply go through the class itself? I mean, we did implement. If you go to the first episode, you see we implement the stuff. It's basically from scratch, almost what you will see if you go into the array list, and that's basically what we will do also here. Now, if you really want me to go also through the class itself, but I don't see it makes a lot of a big difference, no, then we can do that as well, of course. But yes, what we do here is discuss how things work in Java behind the scenes. Yeah, that's what we do and that's what we implement. But implementing it from scratch sounds a little bit more like doable, like workable than just going through something that's already implemented and follow that code. But let me know. Cool. So when we think about a linked list, yeah, you actually, one is the collection itself. Oh hell, why is that red? And how do I make it not red? Maybe here, fill nothing, stroke something. Cool. This is the collection, no? But the collection is actually composed of multiple nodes. And these nodes are actually those who contain the data. So you might imagine this is an instance of an object, and it might contain, let's say, a number. Anyway, you know, when you create a list, you use generic types. So normally when you say data inside the list, it doesn't really matter if it's a number or another object or a string or something else. It's the same thing. Yeah, it contains some data. Now the idea is that you always start with an empty list. No, an empty list doesn't contain any of these nodes, and at some point you have a first node here, and then you can add a different node. So you have now a list of 2 nodes. So what is the difference between the value itself and the node containing a particular value? Well, the difference is that you will have also the link between the 2 nodes, and here is why you call it a linked list, no? Because you have the nodes inside and the nodes are linked one to the other, so that's where the name comes from. Now why is one of them a single chained and the other one is a double chained? Is because well, if you talk about a single chained list, then you will always have from one of the nodes a reference only to its next, but never to its previous. So if you have something like that, you have a node referring to the next, but not the previous, then you can say you have a single chained linked list. So and then you can add one more, for example, and this contains a different value. And of course, if you want it to be in the list, you always have to figure out the chaining, because that's why it's called a linked list. You need to define the link between the nodes. So every node will have a following node of itself. So that's basically how it works when you talk about a single chain list. In the double chain list, which is also the implementation you have in Java, don't only have the link to the next node, but each node has also the link to the previous node itself. So you can actually walk into both of the directions. But to understand better double chain lists, my advice is we first go through the simple chained one. So once you understand how a simple chaining works, you can understand also easier, I would say easier, of course, how a double chain works as well. Now look a little bit at the operations. So what kind of basic operations do we have usually with a list? Now you have a get by an index. You have the possibility to set a value at a specific index. You have the possibility to insert a value at a specific index. And basically these are those that we have discussed also for the array list. Now you want to remove a value from a specific index, and I'm not sure if I may, of course you want to also add a value at some point. So set a value, add a value, insert a value. When you add a value, you say you add it at the very end, no? Insert a value and so on and so forth. So let's discuss these operations in terms of complexity. Now see what actually it takes. So you have a get, and it was pretty easy with the array list. No, it was very easy because you had the array behind the scenes. So in case of an array list, the get operation actually mirrors to having the access to the array behind the scenes on a specific index. So the complexity of the get in an array list is very small. No, it's the smallest possible. While in case of a linked list, well, things become a little bit more complicated, no, because suddenly you don't have an array anymore, and the only thing you have is the links between the nodes. So if you want to access, for example, the value on index 2, because you can still just discuss about indexes starting from 0. They are not stored anywhere, they are not defining something, but it's a way to enumerate the values. And if you want to say get the value from index 2, you start from 0 and you parse the whole collection until you have figured out the exact element that you need. So you see, suddenly with a single chain list, linked list, getting a value at a specific position is more complicated. Now it's a lot more complex than just accessing it straight away. So because you have to parse the list, you need to iterate through each and every element until you've found the element that you need. So this is how it works. So you can already see a big difference between array list and the linked list. When it comes in terms of access to the value, it's definitely better to use an array list rather than a linked list. Now, someone asks in the chat, time versus space complexity. I will make a separate video when discussing complexities, but since you asked the question, it just came to my mind that we can discuss this also for these operations that we have now in a comparison between what we have talked about in the first episode, the array list, and what we talk about now, the linked list. And also in terms of space, you see, now getting to the add of the element, because maybe we will see that better to the add of the element. Remember that when you have an array list, you always have an initial array, and you can decide how large that array should be. I think 10 is the default values in the implementation, but then you also know that adding values at some point you will end up having to enlarge, to grow that array. I think grow is how they call the operation behind the scenes. So you have to make it larger. So you, for example, have to double its number of variables, double the container. Okay, and then it's your decision. How many would you like to add more? Would you like to completely double? So let's say you have an array of 10, then the next grow operation will create an array of 20, and then the next grow operation will create an array of 40, and so on and so forth. I think this is exactly what we implemented in the previous episode. Or would you like to grow linearly or add one more variable every time? Well, it's a very good question actually, because depending on what you choose, it's exactly the compromise you make between time and space complexity. No, because if you choose to double every time you add the container behind the scenes, so remember the array list, no, we have a container of 10 and we decide to double it, and when you reach the 11th item you need to add, the container suddenly becomes 20. But to become 20, so what happens behind the scenes is that you create a new array and you copy all the values from the previous one. So now that you have a lot of space, enough to put your 11th value and some more, which means that the next 9 operations will not require, will be again with very small complexity. So you compensate it with space, because now you occupy space for nothing. You have a container, an half empty container behind the scenes, so you occupy space in the memory, but you occupy that space to make a compromise for the next 9 additions, because you know that you will add things in the future. So adding things, 9 more, will not require time complexity. But if you would have, for example, just increased it with 1, because naturally that's what you need when you have an array list and you have 10 elements and you want to add an 11th. The container behind the scenes is only 10th, so you don't have enough space. So what you do? You grow it. But this time you don't grow it with making it twice the size. You grow it making it just one more, so that your 11th item will fit in. So what is this? You didn't make a space compromise. Now you actually use the minimum space possible, but all the add operations will require a larger complexity because you will have to copy again the values every time you enlarge, and because you have only enlarged with one, all the next will require the same time complexity. So you see, sometimes what you need to do is a compromise between, can I occupy more memory, but I know that in the future that will save me some time complexity, or should I spare all the memory that I can, because maybe additions are very rare in my collection, so it doesn't make sense. We very rarely think about these kind of things when using Java, don't we? But we should. I mean, when using even like lists and the Java collection framework, no, you sometimes don't even think about it. Just it works behind the scenes somehow. I don't care how. You don't really like use a lot of collections or fancy collections or create your own. But normally, if you want to be very efficient, you have all these decisions that you need to take. Now, also normally today, it seems that we are such in a hurry with writing the code that we don't even think of this kind of decisions anymore, because hell, we have so many things to do, and thinking about time versus space complexity for a few variables in an array, who cares about that anymore? No, but normally we should. That's software engineering. So see, that's a very good question that I've seen. Thank you very much, Ali, for that, because it raised me that I didn't discuss that. See, I don't remember to have discussed it, this time versus space complexity when it comes to collections, and maybe we will analyze it also also on this and maybe next things that we discuss. No. So you see, so getting a value is more complex. Let's see, setting a value at an existing position, it also means that you have to go to that specific position and change the value. So you need to find it, same we do with get, and then instead of returning the value, you just set a new value, okay? And adding a value, meaning adding it at the very end, it means the same. You have to parse the whole collection, find the last element, create one more node and link it to that one. Inserting a value. Inserting a value, it's a more interesting one, because if you think about the get, the set, and the add, in comparison with the array list, now getting definitely is worse. Setting definitely is worse, because there are again difference between direct access in an array versus having to iterate through some elements. Adding at the end, it's also in most cases it's less productive. No, so if you think about the add, now adding normally in an array list at the very end, in most of the cases, you either have a complexity of 1, meaning that you already have the array and you just put the value there on the position, or, and that means a compromise with the space, which is what we discussed now, because it means that you somehow grew your container, your array behind the scenes, make it larger than you need it, just to make sure that then the complexity of adding is smaller. But even if you compare it with the situation where you save the space, say you want to grow it one by one, this is approximately now as a complexity with what the linked list does. So you see, if you make a comparison, even the add value on a single chain list, remember we are still only discussing single chain lists. I will go to a double chain list later, which is basically, again, so linked list is here. We don't yet discuss the Java util linked list. Okay, this is here. Now we discussed this one actually, so at this moment this is what we discuss. You will see that having double chain comes with some advantages. Okay, so I don't want you now compare the linked list in Java with arrays, thinking that all of these operations are worse, because they are not, but you will see that. So addition, in the best case scenario, if you think about a single chain list in comparison to the array list that we discussed in the last episode, you can come to the conclusion that it's equal in terms of time and space, or approximately equal in terms of time and space to the case where in the array list you would only grow it one by one, which is not really the way you prefer to use the array list in most cases. Then inserting the value. Now inserting the value is a little bit more it's a little bit easier for the linked list, because you only have to parse. So you say insert a value at index 2, which already exists. So what you need to do in that case is just, oh, sorry for that. What you need to do in that case, so you have this value that you want to insert, whatever, 75. So it's just you find you find the element before, and what you do is that you make it point to your new value. So you parse the entire collection up to the value before the one where you want to insert, and then what you do is that you make the link between that one and this one, and then the one that was, this one was previously linking to, will be now the one the new value has to link to, something like that. See, so now what you actually done is that you inserted the 75 at index 2, and of course that means for 89 now the index becomes 3, which, remember, you don't see it anywhere, it's just the way you number the values, no? So this becomes 3 now. Okay. So in terms of inserting the value, remember what we were doing, removing and inserting the value, was in the case of an array list, like putting all the elements after the value one with one more, eventually having to grow the container, because you don't know for sure. It's like heading, you know, so you don't know for sure if you need to grow also the value. So it might imply that you also need to grow the container, then move all the elements, and then put the one on the position. And then removing was kind of the opposite, but you didn't need to grow anything. In terms of the linked list, you just have to parse up to that value and then rearrange the arrows, meaning rearrange the references behind the scenes. So with that being said, let's actually try to implement something on our own now. So I'm gonna start, okay, today the single chain, next time we discuss also the double chain. I want you to understand both of them, because they are important, essential data structures. Okay, so linked list, I create this class, and what I'm going to do is that inside it I will say private static class node. Okay. I like Copilot. Sometimes when it comes to simple things, it knows what to do. When it comes to like business things, it doesn't know, or at least that's what I observed. But I will explain now. I will try to write as much as possible. I will not allow Copilot to write for me. But I've seen some more comments, so I want to read them. Okay, thanks for your appreciations. Then common interview question like how hash map or some other data structure work internally. Basically, they want to know how deep have you gone with the code? Okay, and then if Java has done something to implement this, what they have done. So well, they did, no, because we have all the collections in the Java util. So last time we discussed the array list, and now we discussed the linked list. Of course, we start with the linked list. We start with the simple chain, but we will also go to the double one. So you see, so this is exactly, you can see this what Copilot suggests me here is definitely a single chained one. So it contains what? The value. Okay, we will take int for the moment just to avoid complicating things. Normally you would have used a generic type so that you can put any type there, no, but let's use int, because the important thing is now you focus on the algorithm, not on the data types. Okay, so you have the value itself, the node health, and then you always have a reference to the next node. So that's basically when that's basically exactly what we were explaining here. So this is the number 10 is the data, is what you would be storing in this value field, while the arrow is basically the next attribute here, which for the first node will always be null, no, because you only have one node. And for then for the next, for the last one, actually will always be null, but for the first, when you have only one, then of course the first is also the last. That's what I wanted to say. And then you say private node head. I usually name it first. I'm not sure if head is better than using first, but that's how I got used to. And then normally now we should be able to also, now I think a setter on this value would be also good, considering that we want to set as well. So public void set value. And normally we should be able to also get the value. I think we might have been able to do so also because we are in the outer class, but anyway, let's use the getters and setters because I think it's better like that. So what do we do now? Which are the operations that you would like? I'm not sure this is needed. It's the same thing without it. So let's just say public void add a value. So I will follow a bit the suggestion, but I want to write it myself. So the idea is the following. So you have int value, and then you have to know in which situation are you. If it's the first node, then you simply instantiate it. If it's not the first node, and here it is, here you can see the loop. So you can already figure out the adding, which is more complex. It's basically iterating through the whole collection. So regardless if it's what is the value, you will always iterate. So remember, in the case of the array list, you are only iterating you were only iterating when you had to glue the container, no? But here you don't do that. So is it possible to explain why the node class is static in this case? Well, normally we create non-static classes when they have when the instance of this class has to be has to be linked to the instance of the outer class. But in this case, the instance of the outer class just uses the node class. So normally you could even take it out completely, but as for, let's say, best practices, you privately create it inside because it's not useful at all from outside to in any other class than this one. So in that case, you prefer to hide it to eliminate confusions that might be created in the future. Now, this is a static class because it's just a normal class independent of the outer class instance. If I would have made it non-static, then it would have been dependent on this class instance, and then each node would have been dependent on the instance of the list, which is something I don't need. Now, if this is something that is unclear and maybe you need a refresher on how nested class works, remember you can find an episode about that in the Java Fundamentals series. I will not go deeper here now. But if you need a refresher on static versus non-static inner classes, go to the Java Fundamentals playlist on the same channel. It's free for everyone, and review that episode there. You will understand better the syntaxes. Okay. So again, I want to add a value. So the first thing is I make sure that the first that I'm in the case where I have the first value, no? So if the first node is null, it means the list is empty. So here I'm in the situation where the list is empty. So I'm just gonna say okay. I don't want to autocomplete it. I just want to write it to be able to explain it better, okay? So I'm creating that first node. If I'm not on the case where the first node is null, it means that the list is not empty. And what do I have to do in that case? Iterate through every node until I find the last one. How can I identify the last node? Well, the only way I think in which we can identify it is where it doesn't have a next. No? So if it doesn't have a next node, then it means that you need to, it is the last one. So this is the one you need to link it to. So you see, the last node is always the one that doesn't have one more arrow. It's not pointing to anyone. So that's the equivalent of the next being null, no? And the next is null, there is no pointing to any other, it means it's the last node. So in that case, you would have to iterate through them, okay? So you say you have a current node, you start from the first, and then while you didn't reach the one that's not pointing to anyone, just make the current to be the next. So you say you start with the first, current is the first. Is it still pointing to something? Yes, then this becomes the current. Is it still pointing to something? Yes, then this becomes the current. Is this still pointing to something? No, finally this becomes the current, and you found also the last node. And then what you do is say on the last node, link it to a new node with the value, having the value that you need to add. So when you have reached this one, you just create one more. With whatever specific value you wanted to add. Also, please take a look. You don't have indexes naturally, so you can only find them through iterating. I put the indexes here just to be easier for you to make the comparison with the collection, but they don't exist somewhere. They are not stored. So these values 0, 1, 2, 3, 4, they are not stored anywhere, no? So it's only about the chain, the link between the nodes, the chain. This is called the chain of nodes. And because it's a chain composed of nodes linked between them, it's called a linked list, okay? It's a single chain because it only has one direction. You will see when we discuss the double chain that there is also the other way around. So you can go from the first to the last, but you can also go from the last to the first. And there are circular lists as well. You will see many more details in the next in one of the next episodes. And the same, if you want to get a value, no, say you want to get the value at a specific index. Now you have the notion of index, but to understand what an index is simply just iterating to that specific value. So you just iterate as long as you have. If someone requests an index and you don't have that value, then you have to throw an exception, no? So normally there is no such thing as an index. The index is not stored anywhere. The index is solely the number, the position, but to find out that position, you have to really iterate and see this is the first one, then the next is the second is with index 1, then index 2, then index 3, and there are two situations. You either find it and then you return it, either that, or you end up figuring out that you don't have enough values, as many as they were requested, and then guess what happens. And yeah, of course, normally you would have also said here, like if index smaller than 0, throw new index out of bounds exception. That was not part of the recommendation, no? So you say current is first, then you iterate through all of them, no? Until you find the given index. So if you end up with no index, yeah, if you end up with no node, then you throw an index out of bounds exception. Otherwise, the current becomes the next one. So there are two options. You either end up having enough nodes, such in the case this for loop will end, and then the current now is exactly the node you are looking for. So the only thing you need to do is returning its value because you found it. Or you end up at some point when next will be null. So the next iteration, you will see it's null, which means you ended up at the end of the chain. There are not enough elements, as many as they were requested. So you throw an index out of bounds exception. Then what else do we need? The set a value at a specific index. No? So again, the same thing. See, Copilot learned from me. Now it knows it has to check also for the index to be smaller than 0. And then, of course, it's kind of the same thing. Remember, normally we would have to write the code in a clean manner. So I would not want to have duplicated code. This is not a course about clean coding. In real-world apps, whenever you do anything like that, make sure that you don't have code duplication. And also make sure that you properly use unit tests to test your code. So now you see it's basically the same thing, because getting or setting the value is literally the same thing. The only thing differs is the last line. For the get, you return the value. For the set, you set the value. So that the two of them are identical. That normally parsing the value would have to be taken out in a separate method. For the sake of the example, I will leave it like this because you might want them to compare them and understand them. But the idea take in mind is that all this part here is actually finding the node, either finding it or throwing an exception if it doesn't exist, getting the value. Then once you found the node, if you found it, you return its value. And if it's a set, you just set the value at that specific position, both of them having the same complexity, as you can see. And then you have, of course, the insert and the remove. So say I want to remove a value, a value at a specific index. Then same thing I need to do is make sure that the index is at least greater than 0. And then that's interesting. So it's a little bit of what Copilot tries to tell me here. It's a little bit of an optimization. It tells me, hey, if the index is 0, then you need to remove the first one, which means you don't have to search for it anymore. You already have it in the list, which kind of makes sense, no? Because you need to you don't need to like parse for it anymore. So you just say, okay, then if index is 0, then first becomes the next, and then that's basically it, because automatically when you did that you also remove this reference, so garbage collector will be able to parse it. So you say if index is 0, it means we are already referring to the first element, then the first becomes the next, and then that's it. You can just skip everything, you can just return. No, so if it's this one, the only thing you need to do is actually remember, because remember there are no such thing as indexes. Maybe here it would be having the indexes might make you might create confusions. So the only thing you need to do in that case is, hey, in that case the list just has to link to this one, and that's basically it. Okay, this is the simplest operation. Now, what happens if it's not that case? Normally you need to parse again through everything like you did in here. So again, the same block of code to find out what you need. And once you found out, so you iterate it same as you were doing, for example, in case of the get or the set. No, say you want to remove the value 89. Oh damn, I destroyed my diagram here. I'm going to put it back. Okay, so say you want to remove 89. No, you first have to go next, you found it, and then actually you go up to one before. No, when the next is the one you search for, then in this one you link its next. That actually means the only thing you need to do for removing is to make sure that you copy the reference from this one to the previous. So that way what will happen is that instead of having the arrow here, you have the arrow here. And now automatically, since there is no more reference to this node, the garbage collector will be able to at some point take it out completely, and you end up with this. No, so that the only thing now you need to say is current next is the next of the next. Yeah, so this is the current here, the 75 is the current, and its next is no longer the one it has, is the next of its next. So putting back this one, so for 75, 89 is current next, and 77 is current next, and 75 of course is current. So you iterated through the whole collection until you found the one previous to the one you want to replace, and then you just say that the current this one's next has to be this one, which is the current next. Once you did that, it happens exactly what we were discussing previously. So you draw the arrow like that, and of course at some point this disappears, and this is no longer now the next. It's basically, it became current next, because that's basically what you did here. So you said current next becomes the one after, and that's actually the removal from a specific index. So it is that because for loops are iterative and fast, so you have used that. No, I mean, you can actually use any kind of iteration. Is that just that when you use the indexes, which happen to be consecutive numbers, for loop is just easier to use, no? I mean, you could have used a while, but then you had to keep a variable and increment it and do whatever for does here. I didn't use the for loop because it works better. No, any kind of loop will create the same complexity. I used it because I really have to iterate from one number consecutively to a specific other one. And whenever you do that with any programming languages, you usually use a for that. So it's just the comfort of using the for loop for iterating through an interval of numbers, which is something that we use usually. So this was the remove, and of course you have also the insert if you want, which will have a very similar complexity to the remove. So at a specific index you want to put a specific value, and then again you will do the same thing. You have to make sure that the index exists. Okay, if the index is 0, see that's where you can see what happens. So let's start with the simple case where the index is 0. So what you do is you create a new node with that specific value, is the one you will insert into, and then this new node's next becomes the first. So imagine I have to insert something. Okay, let me take this out. So imagine I have to insert something before 10. If I need to do that, I will simply create one more node and I will make its next. This is say a 5, and I will make its next point to what now is the first. And then I will simply store this new node into the main containers, the main lists variable, which is the one you have defined here. So you just say the new node next is the first node next, and then first becomes, the new node becomes the first one. And this way now new node is the first one, and what used to be the first one before, it's the next sorry, the first one like this, no? So new node's next is the first one, and then the first one becomes the new node, something like that. Okay, and then you have the case again for the whatever it takes to parse. So I'm just gonna copy the code because it's identical. Oh, and by the way, I think we should also return it here, no? Because you don't want, so if it's the first node, it's fine, you have found it, you have replaced it, and then you can completely skip everything that comes afterwards. Or you can use an else here if you want, whatever it feels more comfortable for you. So again, now I'm not talking about clean coding now. And then okay, and then of course you create the new node like you did in here, and what you need to do, so you found say 20 and you want to insert it afterwards, then you make 20 point to the new node, so the current node should point to the new node should point to the current next, and that's basically it. So you just replace the references. So you have the new node, then the new node next, its current node next. I'm not sure because I'm pointing to the one previous, or it goes actually to the index -1. So let me actually check. 0, 1, 2. Let's say I'm replacing the one on 3. So I'm going to 2 here. So I would actually say that the new node next is the current next, no? Something like that should be. So the new node next is the one after. No, because I inserted after. Yeah, it was right, sorry. So I insert it after. And then the current node next becomes the new node. Because I'm inserting, yeah, it's fine. And then basically I think that's it, no? Because you don't have anything else to do, so you just have to replace the references. So yeah, that's basically how the single chain linked lists work. Now you draw the conclusion. So you can draw the conclusion whether you better use a single chain linked list or an array list, because it's very easy. Now you now saw the operations and you see what the complexity is. You can see that in many cases the complexity in terms of time is larger for most of the operations. But one of the advantages that you can observe is that the advantage in terms of space is smaller, because sometimes with array list, and if you don't mind on how you grow the array list, then you might end up spending a lot of memory, like borrowing a lot of memory for the container for next operations that maybe will never come. So depends, of course, on the case you have. If the space complexity is important for you, and maybe more important, then it maybe makes sense to use a single chain linked list. Now you will see that many operations that we have more flexible operations on the double chain list, which basically is what the Java util list is. So remember, today we didn't have the time to discuss in detail about the real linked list that maybe as a Java developer, when you say linked list, you of course think about the one from Java util. So we only started with discussing the single chain lists, and now to allow me enough time to discuss double chain linked lists, I will take it in the next episode. And for the today's I will just close, but I will put, of course, the code on my GitHub account, so you can check it as well if you'd like. But the important is behind the scenes, understand what happens, and not the code is important here. Remember that I didn't write it clean, that I didn't put too much soul into it. It's just to explain how it works, to understand behind the scenes how these collections work. You don't have to, in reality, know by heart how to implement such collections, but writing the code helps you also understand it better, and that's why I always write also code and not only use diagrams and visuals. I'm gonna say goodbye now. So thank you very much for being here with me again, and I saw a lot of comments and questions, and I'm looking forward for your comments and questions in the next episodes as well. Remember that you can follow me on Twitter, on LinkedIn, and of course that you can still leave comments in the comment section after the live event if you haven't been here with me live. And if you've been or if you haven't been, I'm still looking forward to seeing you live in the next episodes. Thank you very much. Have an excellent time for learning further.